Hello everybody, I'm feeling rather pleased with myself today because I've just made one of these. This is a spring centre. Some people call it a spring loaded centre, other people call it a tap follower. Now what does it do? It does amazing things. You watch this. If I hold this end, that piece goes in. If I release, it comes out on its own spring. Isn't that amazing? Oh, what's it for? Let me show you. Here we are on the bench drill. We've got the chuck of the bench drill here. If I turn the handle, the chuck comes down. Turn the handle the other way, the chuck goes back up. Now let's assume that this chuck held a drill which has drilled a hole in our job, and that hole we now want to tap. Here's the tap that we're going to use, and this tap has got a divot, a little centre drilled in its top. Now when we tap the hole, we want this tap to be as vertical as we can get it. Now if we tap normally, we would put this into a tap wrench, we would then put that into the hole, and then we would start tapping our hole, and we would look from the front, we would look from the side to make sure that it was vertical. However, if we take our little device, our spring-loaded centre, and put that in the chuck, the pointy end will now fit into the divot, that centre in the tap, like that. So if we put our tap onto the hole, we then bring down the chuck so the centre goes into the top of that tap, and then carry on bringing it down, so we're charging up that spring, and now we lock it down. So the tap is now held perfectly vertical in the hole, and we have two hands to tap the hole. Now as we start to tap, as soon as it starts to tap and this tap digs in, it will start going down. Well, the support on the top of the tap stays there because the centre is spring loaded, so it will follow it down. And even better, when you come backwards to clear the thread, the tap will rise, the centre will go into the body and enable you to tap nicely right the way down to the bottom of your hole. It's a really useful tool. I can hear people crying, hang on, hang on. If you get a small tap like this one, it hasn't got a little centre in the top face here. What are you going to do then? You can't put that underneath your spring-loaded tap. Well, all is not lost. If we loosen this off, take our big tap away, what we do is use this type of tap wrench. Now, with this type of tap wrench, it has its own centre in its top, and we put that in our centre, we charge the spring, lock the chuck down, and now we can tap. The tap will go down, the support will go down with the tap, come to clear it, the tap will rise because we're unscrewing it from the thread we just cut. The centre will take that into account, and we can carry on tapping nicely with two hands right the way down to the bottom of the thread. Do you see? It's wonderful. But there's even more. If we take out our tap, if we take out our centre, now imagine this centre has been put into the tailstock chuck on a lathe. We can now tap holes on the centre line of the lathe. Not only that, we can go to the milling machine and use it in a similar fashion as we used it in the drill. Any hole that we've drilled on the centre line of the vertical head, we can tap, and that tap will be vertical and directly in line with the hole. If the milling machine was at an angle, so we've got the vertical head at an angle, we've drilled a hole, and now we can tap that hole. Do you see? This is a wonderful bit of kit. And I've made this one, and this video is going to show you how I made it. Now, if everything has gone to plan, a smug looking Jim has just been showing off the spring-loaded centre he's just made. Well, I'm the Jim of several days before that smug one. I haven't got a spring centre, but what I do have is a workshop, some materials, and a few ideas on how I can make a spring-loaded centre. When you design something, the first ideas you come up with are generally not the best. Because of this, I like to sketch down at least 5 ideas, ponder them for a while, and then choose what I think is the best one, or choose the best bits from more than one, and then make a new sketch incorporating them. These sketches are the 5 ideas I've come up with. All will work, but I prefer these 2 on this side, and I've decided to make this one. So I think a new sketch is in order, and then a search for some materials. And this is that sketch. Now, the main body of the centre is going to be made up out of this stainless steel M12 bolt. Stainless steel, so it's not going to go rusty. I'm going to be turning the head down so it's the same diameter as the shaft, and as you can see I'm going to remove the thread from the shaft except for this piece at the bottom. This end of the shaft is going to have a centre drill drilled into it, and the small hole will be extending into this main chamber. Now, as the plunger goes up and down inside the chamber, it's going to need somewhere for the air to go, and that's what that little hole's for, so the air will be able to go in and out there. Also, we'll be able to put oil down through that hole and lubricate the plunger later on. The next thing we're going to look at is the plunger itself. That's going to be made from silver steel. I have it here from my silver steel drawer. And the reason I'm going to use silver steel is I can harden the end, which will make the sharp end far more durable than if we just used normal steel. You can see here, this is the plunger. We'll be turning this down. This end is left slightly large. In fact, it's 6mm as against 5, and that will be used to retain the plunger within this chamber. This top is going to be made out of brass, and I have the piece of brass it's going to be made from just here. That's going to be screwing onto that M12 thread, so we need to tap an M12 thread into that. And there's 2 cutaways here and here. As you can see on this little sketch, what looks like the window in the cockpit of an aircraft is actually a flat that's machined there for a spanner, and that will enable us to do this head up against the thread that's left on the shaft. The last thing we need to look at is the spring, and I went through my drawer and I found this spring. It's a little bit short at the moment. I'm just going to stretch that out 5mm, and that will be fine. And that's all the parts of our spring-loaded centre. The first job we're going to do on the centre is going to start machining the body. This is the M12 stainless steel bolt. It's just going into a 12mm collet, and the first job on this is to centre drill the head. I'll put a centre in the drill chuck there, and we'll turn the lathe on and drill that centre. We're now going to reduce the diameter of the head, get rid of this hex head and take it down to the diameter of the shaft. We have taken the head right down now to the level of the thread, so it's time to just bring the bolt out of the collet. I have now wrapped some masking tape around the bolt, 15mm from the end, so I know exactly where the 15mm mark is, and now I can replace the bolt in the collet, and as the tape comes down to the edge of the collet, lock it up and remove the masking tape. Right, the next thing we want to do is turn this between centres. Now before the centre goes in, I need to put some grease in here, and the grease that I'm using is Castrol LM grease. This is high melting point, high pressure grease, use it for wheel bearings. So in this particular instance it's going to be a good grease to use. Now then, we're bringing the towel stock and the small centre that I'm going to be using. We're going to be cutting down this diameter, so I want it, I need the centre to be quite small so we can get the tool in. A life centre is able to rotate with your job. I don't have a small life centre, so I'll have to use this small solid one to support the job. The grease is to lubricate the centre, which should just touch the job. Do not make a solid centre tight against the job. It will overheat and damage the job and the centre. Now the drill chuck is in position, the cutting tool can't reach the job anymore. I need to change to a different tool. This one here, this tip tool will do quite nicely. Now when you're using a centre like this on the end of your job, it's a good idea to run it for a few seconds, then stop, and then put your finger on to see if it's getting warm. Because what you mustn't do is put a lot of pressure on here. If you do, then you're going to start to friction weld the centre into the end of your job. So turn it on for a few seconds, turn it off, put your finger on, see if it's getting warm. If it's not, then you're going to be okay to continue. Perhaps do it for a few more seconds just to make sure that it's not getting warm. If it is getting warm, you're going to have to readjust the centre. It should be just touching the job, but not tight against it. So let's turn the lathe on and let's start doing our first cut. Right, we're taking off the top of the thread quite nicely. I need to clear this swarf out. We are getting fairly close. We can still see a little witness of the thread right down there in the root. Now this part of the centre we want to keep above 9mm if we can, because there's going to be a hole drilled up the centre which will be holding our spring. So the larger we can make this, the more meat we've got between this surface and the hole inside that'll hold the spring. So I'm hoping to get over 9mm. Now at the moment we are at 9.8. So I think I'll take off 0.1 and see how much of this thread is left. Well, we've taken that 0.1 of a millimetre off, so we should be down to something like 9.6, 9.59, 9.63, and there's still a little bit of thread, but just on one side of this surface. So I'm going to take off, I think, 0.05, and hopefully that will clean it up altogether. Right, let's give that a measure. Well, it looks like all of that thread has disappeared now. If I just spin the head round. Yep, that's looking good. Let's just give it a measure. We should be round about 95, I think. 95, 9.5, 9.54. So that is excellent. We've now finished our first turn surface on the centre of the spring-loaded centre. Now, we have our centre hole drilled in the end, which is good, and we have sufficient thread on the front so we can face this end off before we drill the hole up through the centre. Now, I'm not going to drill the hole at the moment, and I'll come back to that in a bit. What we're going to be doing now is we're changing across from this component to the piece of brass we have, and we're going to make the front cap. That's this bit as shown on the drawing. We now have our piece of brass in a 16mm collet. First thing we're going to do is face the end off and then drill the centre with a centre drill. And now let's drill the front face with the centre drill. That's all we're going to need. We just needed a centre there to guide the next drill. So we've got our centre in. I'm going to be going in with a 3mm drill next, and I'm going to go in full depth. Now we want this thread about 15mm deep. If you look on the drawing, you can see that we're making this piece just here. So we're going to go in with a pilot drill, 15mm, bring that out, then put in a 10.2mm drill, which is a tap in size for M12, and then we're going to tap the hole. 3mm drill first. Well, here we are wanting to tap our M12 thread into our job, which is in the collet at this end, and this is the very scenario where we need a spring-loaded centre just here, but of course I haven't got one, so I'm using my little old centre. The M12 tap is the taper tap That's the first one to go in. We've got our tap wrench. The tap wrench is being supported at this end by the small centre. The small centre's in the chuck, and the chuck is in the tailstock of the lathe. Because I haven't got a spring-loaded centre, I'm going to have to keep the pressure on the centre here by my other hand up that end, turning the wheel of the tailstock. So we press it, and I can, because this is also quite a coarse thread, and I can feel it cutting. And now I want to come back to clear the thread, and again, if I had a spring-loaded centre here, there wouldn't be a problem. I could just turn it back. But now I want to turn it back to clear the thread. I've had to wind the tailstock back a little, and now I will clear the thread, go back in, bring the tailstock up again with the centre, and continue tapping. And you can see you can get away with not having a spring-loaded centre, but I tell you what, it's so much easier with one. Anyway, I will struggle along and get this tapped to the bottom of the hole. I've tapped to the bottom of the hole with the intermediate tap. This is now the plug tap, so the thread goes almost right to the end. Now I won't need to hold this with the centre because the thread in there is nice and straight. So I'll take this down to the bottom of the hole. I can feel it cutting there. And we just get the last few threads right to the bottom of the hole. Just there. That's right. And now we remove the tap. And now the test. Does the body of our spring-loaded centre fit into the thread we've just cut? Oh, and it does. Look at that. Straight in. Excellent. That's good news. Now, if we look at the drawing of the front cap of the centre, you see that it's 15 millimeters of thread, and there's another 15 millimeters for the front surface. I think what I'm going to do is, instead of cutting it off 30 millimeters long, I'm going to make it 35 millimeters long, and that gives me a little bit of spare, and I can always cut that off later. And time to part this piece off. Just like that. We now have the body of the centre back in the lathe. It's held in the collet on the surface that we've just turned. Now if I screw the front piece of the spring-loaded collet back on the body like this, there is a little bit of thread which is showing in here. And what I want to do is face off the stainless steel shaft here, take this surface back until this face of the brass cap is level with the end of the thread. So that's what I'm going to do now. And now the thread on the body of our new centre lines up with the rear surface of the head. We're going to start doing some work on the plunger now. I've put the silver steel into the collet. You can see it sticking out here. And our first operation is just to centre drill the end face of the rod. We now have a nice centre drilled into the end of the silver steel bar. And this is our setup. The silver steel is now in the collet here. We have the centre drilled at this end. We have a centre in the chuck, and the chuck is in the tailstock of the lathe. I've put grease between the centre and our silver steel. I've run this for a few seconds, in fact about 30 seconds, and this doesn't get warm, so I'm happy that there's no pressure there. The 70 millimeters we've got here, this is going to flex as I start to cut, so it will get bigger in the middle as the material pushes away. So what I'll do is, once I'm close to the end, I will go backwards and forwards with the tool, and then just the natural springiness of the material should cut it off, and we should end up with a parallel piece of silver steel 5 millimeters in diameter. And we're about to start cutting. Our silver steel bar is 6.5mm in diameter. Got to get that down to 5mm. I'm not going to be taking much off at a time. I think I'm going to go, I'll try 0.1 of a millimeter just to see how we're cutting, and then I may go up to 0.2 on the next pass. Oh gloom, look at that, my centre has overheated the end of the job. I think what's happened is normally I would be using coolant running over the top of the job, which would take the heat away, but because I've got the camera on and I wanted to have a good view, I was putting the coolant on with my toothbrush. Well, it obviously wasn't enough. I think what's happened is the silver steel's expanded, the slack that I did have in there disappeared, and then it's broken the grease down, and it's I think it's welded on because it doesn't want to come out at the moment. Well, that's a pain. Well, I was lucky. The centre had started to stick itself to the end of the job, but once I got it out of the vise it just broke away really easily. There was a couple of pits on the surface of the centre. I rubbed those back with some emery cloth, fine emery cloth and oil, and that's cleaned that up. The end of the silver steel bar, I put the centre in there again, the centre drill, and clean that up. So we are all set for another go. This time I'm going to be dousing it in cutting fluid. That's what the spout is here, you can see, and I'll be checking it at the end of every cut, I think, to make sure that we haven't taken up the slack. I've also given it a little bit more slack than I would do normally. Right, let's give it a go and see what happens. Well, it seems to be working now. I've just checked the diameter of the silver steel. It was 5.1mm, which is really good, so I won't be taking any more off of this surface. I do, however, need to square up this end of the cut. And the progress of our plunger. We've now turned this shaft down to 5.16mm. The next job is to cut the bell off the end and also cut our plunger off of the silver steel 10mm up from there, in fact just over 10mm, and then face it back. That's the next thing to do. I've cut the plunger from the length of silver steel. This piece at the end is actually 15mm long and not 10mm long, like I said before. This end face still needs to be faced off in the lathe. I'll be doing that a little later. What I'd like to do now is put the point on at this end. Now that point is going to have an included angle of 60 degrees, which I want to turn. The problem I have is how am I going to hold this in the lathe? If I hold it on this face here in the collet, then I've got all that sticking out and it's liable to bend when I try and machine this end. However, if you look at the collet, which is here, this is a 5mm collet, so I can clamp on the thinner part of the plunger. The clamping face on the collet only comes down 20 or 25mm. So what that means is I should be able to load the plunger in from the rear of the collet and have it sticking out the front, and then I can put it into the lathe. Let's see if that works. Well, that's looking promising. Our plunger is held nice and secure in the collet just here. I've set the compound slide to 30 degrees. And now all we have to do is turn the lathe on and start to machine our point. I've removed the plunger through the rear of the collet, reinstalled the collet in the lathe, and then inserted the plunger, pointy end first, back into the collet. We can now machine its rear face. I just need to face this end now. I want this part of the plunger being 15mm long. I'm going to be measuring it with a rule because it doesn't have to be that accurate. And I've got about 1mm to take off. Only one place left now to turn on the plunger, and that's this diameter here. At the moment it's 6.6mm and it's got to be cut down to 6mm. The plunger is now complete. We have this diameter at 5.1mm, we have this diameter at 6.1mm. We also have the point at the tip, which has got an included angle of 60 degrees. We are back to work on the body and the head of our centre. Now, do you remember I said that I didn't want to drill the hole up through the centre of the body? Well, the reason that is because now I want to machine the head in place on the body. So this is now screwed onto that M12 thread. Now what I suspect is going to happen is this will not run true to the centre of the body. So what I want to do is put this in the collet, turn this down on the outside and also face it off to make it all nice and square to each other. And as suspected, there is a little bit of run out between the body of the centre and the brass head. So I'm just going to turn down these two faces and get them all nice and square. The end face and the side of the head are now nicely turned down and all in centre with the shaft. The next thing to do is to centre drill this end face. I now want to drill a hole in the front of the head, and that hole is going to be for the plunger, which will fit through there. Now we know the plunger is 5.1mm in diameter, so what I'm going to do is go through with a 4.7 first, because as we know drill slightly oversized, and then slowly work my way up in tenths until the plunger slides nicely into that hole. The 4.7mm hole is too small, and the plunger doesn't fit into the 5mm hole. Oh no, I just went to my 5.1mm drill bag and it's empty. So I haven't got a 5.1 drill. No, we're getting very close. I do, however, have a 13/64 imperial drill, and that's 5.159. So that's close enough. I'm going to try that. So the drill going in now is a 13/64, 5.159mm. And the plunger goes into the 5.159 drill. The 13/64 drill is the right size. There's hardly any clearance there, which is good. Now we drilled this hole in the front of the head for the plunger, and a very nice fit it is too. The next thing I want to do is actually shape the head. Now on the drawing you can see up here in the corner I've got like an egg shape. So that's what I want to do on here. Now the way that I'm going to achieve that is by using the compound slide at different angles and then join up the angles with a file to end up with that nice egg shape. At least that's what I'm hoping. A couple of minutes ago it dawned on me that I haven't covered up my bed. It's really important if you're using abrasive materials at the headstock of your lathe. The particles of abrasive material will fall on the bed. If you then move the carriage up and down, they can get between the carriage and the bed. If they get embedded into one or the other, it's going to cause a lot of wear. So if you are going to use abrasive materials close to the headstock, or if you're going to use it anywhere, make sure the bed is covered up. I've washed my bed down now with oil, make sure that it's all clean, which it is. So I'm going to carry on with this cover over the bed. I've taken the head off the body so we can have a closer look at it. It's all nice and polished and it's all nice and finished. So we can put this to one side now and get back to the body of the centre. I now have the body of the centre in the collet, and in this chuck here I've got a centre drill. The next job is to centre drill the forward face of the centre. Once that's drilled, I'll then take the centre out of the chuck, replace it with a 6mm drill, and then use that to drill the chamber inside the body of the centre. That chamber's for the spring which will push the plunger down all the time. Now that hole has got to be 55mm deep from this face. Mustn't go much further than that because it's liable to pop out the top of the centre, and that won't be very good at all. 6mm drill, and it's got to go 55mm deep. The 6mm hole has now been drilled. Let's see if the rear of the plunger fits in. Oh yes, it does. Look at that. Oh, that's good. I want a little bit of slack in this hole, so I've now put a 6.2 drill in the chuck, and we'll drill all the way to the end, 6.2, and hopefully that will give us enough clearance for the plunger to move nicely. At 6mm in diameter, the hole up the centre of the body was just a little bit too tight and the plunger wasn't travelling up and down in nicely. So I've now opened it up to 6.2mm, and now it's a lot freer, and I think that's going to be fine. The only thing we have to worry about is if we make the slack too much, the spring could get trapped between the inside of the body and the outside of the plunger. But I think that is going to be fine. These are now all the parts that make up our spring-loaded centre. Next job is to do a little bit of heat treatment on the plunger. I'm all set up now for doing a little bit of heat treating. This is the plunger. It's made from silver steel, and I want to harden the end, the pointy end here. So what I'm going to be doing is hardening it with a flame. It's going to be heated up to red heat and then dumped into the water to quench it. Now, when you're heating things up like this and you're going to hold it with your pliers, the heat that gets into the pliers will mess up the temper of the jaws and make them go soft. This is a pair of pliers which I keep to one side, and these are my heating pliers. You can see by the tempering colours on there. So these are the pliers that I use when I'm heating things up and I have to hold them. Shiny round things, when you're holding them in the pliers, have got a habit of spitting out. So what I tend to do is put a piece of wire around, and that gives me something to hold. Still got to be careful, because as you heat this up the wire becomes loose and your bit's liable to fall out, so you've got to keep your wits about you. So the idea is we will turn the blow lamp on, heat this end to red heat, dump it into the water to quench, and that should harden it. I have the lighting subdued, I have the blow lamp on, and we're about to heat the plunger. That is the hardening process complete. Just let that dry off. One of the ways of checking the hardness of materials, a quick and easy way, is to use a file on the material. The thing is, if you've got a very hard material like this is at the end, if you file it, it's going to blunt your file. So might I suggest that if you do this, use the very top part of the file, the part that you don't use very often. Now, with the plunger, we haven't heated this end, and if I use the top end of the file, it's taken the edge off here, so I know that the end is nice and soft. If I do the same thing again with this end of the file, and then I'm going to go on this lip just here, well, it's taken the black oxidizing off, but it hasn't scratched the metal at all, and that's really hard. In fact, it's so hard that if we had this assembled as the centre and I dropped it on something hard, the end could actually chip off. So what we're going to do now is anneal this slightly, and we're going to bring down the temper. We're going to warm this up to a straw, but of course we can't see many tempering colours at the moment, so we're going to have to clean it up. I'll put it in the drill, run over this with a bit of abrasive paper, clean it up so it's nice and shiny, and then we're going to warm it up to a straw colour and then quench it, and that will temper it. It will still be hard, but it shouldn't be that brittle. I have the lights back on now. We needed the lights off because we wanted to see the amount of red that the metal was producing. Now we want to look at the oxides that form on the surface, so we need the lights back on. What we're going to do is heat the end of the plunger and then keep looking at the colours, and then as it warms up, oxides will form on the surface, and depending on the temperature of the metal will depend on the colour of the oxide. What we're looking for is a light straw over this end. Once we get to a light straw, we then quench the piece in the water. Right, let's crank up the blow lamp and start heating this. Just going a straw colour there and into the water. And now hopefully that has tempered the metal a little. It's still going to be hard, but it shouldn't be brittle. It should be nice and tough. These are all the parts that make up the spring-loaded centre. Now there's one job I haven't done, and I'm not going to do it, and that was to put two flats on this end of the head so we could get a spanner on to tighten it up onto the body. It doesn't need that. I've actually put it together already and it goes together nicely, finger tight. So let's put this together. We have the body, we have the spring which goes up the centre of the body, the plunger now fits into the body, and the head slides over the plunger, and we can screw the body into the head. Just like that. Now, does it work? Look at that. My first ever spring-loaded centre. Ta-da! And at last I have my very own spring-loaded centre. If you've enjoyed this video, can you please press the thumbs up icon? It'll only take you a second and it's really useful for the channel. Could you do something like this? Of course you can. And with that, this video is at an end. Take care everybody, and I'll see you next time. Could you do something like this? Of course you can.